into the Baltic Sea to spawn, but then in the low salinity of the Baltic Sea they disappear from the gills of the fish. So this is a really high salinity parasite with a lot of fluctuations in abundance due to the environmental factors. Thank you very much.
Is shown by different type of symbol. So you can see that parasite D has 4 same symbols. It means that parasitizes 4 closely related phylogenetic fish species. In contrast, you have parasites A, which is parasitizing 4 different symbols. It means 4 unrelated host species. So classically we use semi-quantitative separation of host specificity, which is shown on the picture on the left side. So you can distinguish so-called strict specialists, which parasitize a single host species. You can recognize intermediate specialists, which parasitize 2 closely related fish species, mainly congeners. Next, you can recognize intermediate generalist here, which is able to parasitize more fish species. They are not congeneric but belong to the same monophyletic group. And finally, you can recognize so-called true generalist, which is parasitizing several unrelated fish species.
With the ovary and testes pushed right to the back of the body. And here we get advanced intrauterine development, and
the Onchomycelium at hatch can either be non-ciliated or ciliated. If the Onchomycelium is non-ciliated, it will attach next to the host or next to the parasite in the same host. If it's ciliated, it will leave the urinary bladder to infect another frog.
In the literature, all based on molecular evidence, there have been a number of different topologies proposed for these 4 groups, right? This is all based on molecular data, okay? Right? So no consensus. So understanding how these guys actually have evolved, or how these groups have evolved, is quite significant.